Now, if we take acidification, the first one, I think there is a slide on that. Yep. We've got that, and this is basically a shortened version of your notes. There's two things to consider. Before we actually consider the acidification, what is the substance in chemical terms that we're dealing with here? What is it that's causing acidification?
Yes, CO2.
CO2, yes, carbon dioxide. Now, carbon dioxide is having two effects on the ocean. One is acidification, which I'll come to in a second, but the other is actual warming of the ocean. Now, the ocean is absorbing the excess heat that carbon dioxide is creating. You're probably completely familiar with global warming and how carbon dioxide acts as a greenhouse gas. And we're pumping out whatever million tons of carbon dioxide globally a year. And that has a thermal effect. But most of that heat, 90% of that heat that has been generated over the decades, has been absorbed by the ocean. The ocean has become a sink for all that excess heat. If it hadn't been a sink, then the actual atmospheric temperature that we are living in would have risen by 36 degrees centigrade. 60, I think it's 65 or something degrees Fahrenheit, above what it is the average today. In other words, we would have frazzled. We wouldn't be living here now. And the only reason we are is because all of that excess energy that we've been releasing into the atmosphere through burning fossil fuels has been sinking into the ocean. So the ocean is serving, in planetary terms, as a huge regulator of the consequences of the way we're living at the moment. Nevertheless, the sea is actually warming as a result. I mean, the sea, the oceans, cover 72 or whatever percent it is of the planet to enormous depths. So the body of water that you're talking about is absolutely mind-bogglingly big, that it's too big to quantify. So as a sink, it is capable of doing this. But nevertheless, it's warmed by 1 degree centigrade. And if this goes on, that's when I say this, the carbon dioxide story, then we're going to continue to increase global temperatures. And that warming the ocean has an effect on marine life. Now, if we come to the acidification question, again, it's carbon dioxide going into the sea, and here it forms carbonic acid. Now, the seas are naturally alkaline. So when we use this term acidification, what we're actually meaning is we're reducing the alkalinity of the ocean. And the alkalinity of the ocean at the moment is, I think it's 8.1 pH on the scale that they use. Neutral is 7. If you're above neutral, you're alkaline. If you're above 7, you're alkaline. If you're below 7, you're acidic. Now, what's happened by absorbing this carbon dioxide, we've reduced the pH value by 0.1, which doesn't sound much, but it's a logarithmic scale, and it has consequences. And if we go on with the fossil fuel manner of living, then it's predicted that the pH value will fall by 0.3, possibly 0.5 by the end of this century. Now, what is the consequence influence of reducing the alkalinity of the ocean, turning it more acidic?
Bleaching.
Go on. Sorry, who's that? Someone saying bleaching?
Result in bleaching, crustaceans or...
When you say bleaching, can you elaborate a bit?
Stuff.
Pardon?
Like more acidic water will affect like corals and invertebrates, which are like low food chain.
Yeah, it will affect them. How? What's it doing? What's actually physiologically happening? Dissolving the calcium, yes, which forms the bones, our bones, their bones. And whether you've got an exoskeleton, i.e. the shell, that's an exoskeleton, or an internal skeleton, as in fish, that's all made of calcium. And so when you reduce the alkalinity of the ocean, you reduce the ability of marine organisms to take up calcium out of the ocean, i.e. they get osteoporosis. Their bone structure deteriorates, and if the alkalinity continues to decline, it collapses. Now, as you'll appreciate, there are the overwhelming majority of creatures of whatever kind in the ocean are relying on calcium take-up to keep themselves alive. And it even goes down to the smallest micro creatures in the sea. The zooplankton and the phytoplankton, even the plants, have calcareous shells. So increased acidification, reduction of alkalinity, threatens to cause a physiological illness throughout the whole planetary marine ecosystem. And if we're talking in terms of the collapse, which was being prophesied in our film, that is probably of equal, if not more importance than overfishing. Because if you physiologically cannot form the basic structure of your body, then that is as disastrous as the fact of not being able to breed. And so the question of how we as a global society address this carbon dioxide issue is of fundamental importance. So it's not just you need to see the dimension of how it runs into the ocean. And when it affects corals, which was mentioned here, which leads to coral bleaching, that means the corals are actually dying. Now, corals are particularly important because although they only occupy about 1% of the ocean floor space, they are actually vital in terms of habitat structure for supporting marine species. And it's estimated, I think it was I got the figure from the WWF, about 25% of fish and other marine species. So if coral collapse, then you've got a very serious change going in. And coral collapses not just because of loss of calcium, but also because it's only able to live in a very narrow temperature band. So the rising in the temperature of the ocean is equally critical to coral. Fish in the North Sea, which cod, for example, doesn't like to live in temperatures that go much above what they are at the moment, and we've noticed that they're migrating northwards as the temperature is rising. They will move into cooler waters. They're able to actually relocate. But things like corals, that's not practical. So that's a further dimension there.